here we're going to be looking at probability, specifically to do with conditional probability. So following on from the first video I did where I looked at different types of probability, now we're going to be looking at the probability of an event happening given that some other event has to have happened before it. That's conditional probability. So it's written with a line in between the two. So the probability of A, given that B has already occurred, is written P with the brackets outside of A, then a vertical line, and our B. So the probability of A, given that B has already occurred. So we're looking here at the probability of an event which is affected by another event that has occurred or not. So I'm going to go into an example now. And in this example we're looking at two spinners are just thrown, they're numbered 1 to 4. Now they're thrown together and the sum of the numbers is recorded. So what we might do is write up a sample space for that. So if we have number 1, 2, 3 and 4, and here we've got our second spinner, and when they're thrown together we accumulate the total sum. So what we're going to do is we're going to see what is the probability of getting a total sum of 5 given that they've landed on a 2. So in this instance I'm going to say the probability of a sum of 5 given that at least there's 1, 2. So we have our sample space filled out, and I'm going to highlight all of those that have a sum of 5. So all of these, but we're only allowed to choose the ones that actually have landed on a 2 first. So the ones that have landed on a 2 will be this one and this one. So here we're only going to be looking at the selection which had a 2. Our total number of possible events there is 7. I'm not going to be counting the number 4 there twice. So my total probability there is 2 out of 7. So I'm going to look at the Venn diagrams again just to show you how we answer that question. And I'm just going to draw them again. So we have A and we have B. So here I'm saying that B has already happened, i.e. that they contained a 2. So we're only including the B there because we're saying B has only happened. So our total number of possibilities just has to be the set containing all of B. So just looking at the formula there for that, it's going to be probability of A given that B has already occurred. Well, the total number of outcomes has to be B, probability of B, because that has to have happened. And what we're looking there for is the probability of A and B happening, which is A intersection B divided by that. So to bring that back to our overall problem, the probability of A and B happening in this case was, if we look at all our solutions, it's going to be the 2 that I've circled, which is 2. That's the probability of A and B happening. And the probability of B happening, which was all of those that contained a 2, was a total of 7, because we didn't want to count it twice. Okay, so I'll continue by looking at some past paper questions in another video on that, but that's just one short look at conditional probability.